Hey guys, welcome back. In this tutorial I want to show you how I edit the photo I took about 2 weeks ago. It's a photo of M42, M42, 42, M42, the Great Nebula in the Orion. I took this photo using ED80, Skywatcher's ED80 refractor, Canon 450D, modded Canon 450D, and the mount, it was Skywatcher's EQ5 with the OnStep drive. So all this equipment is quite old. The release date of Canon 450D was like it was released 15 years ago, so it's really not equipment which you can call new, but still, as you can see, this photograph is quite okay, I think. So you can get quite good results from such an old equipment, and I want to show you how to do it, how to process the M42 Nebula in free software. So first, let's look at the subframes I took. Altogether, I have about 2 hours of data. I did the imaging during 2 nights in the end of December 2024. During the first night, I took 60 frames, 10 seconds each, so it's about 10 minutes. 60 frames, 10 seconds each, and these frames were for the core of the nebula, where the so-called Trapezium stars sit. I don't know how to say it. This is the Trapezium stars. It's a small cluster of stars right in the center. This whole area is very bright. So if you image the Orion Nebula on a longer subframes, the rest of the frame becomes visible, but the core is burnt out. I think burnt out. It's too bright. So in the first step, I took 60 frames, 10 seconds each, to get correctly exposed image of this core of the nebula. And I also took, during the first night, I took about 14 frames, 120 seconds. So 2 minutes, one frame, 2 minutes, to get the rest of the surroundings and the nebula itself. As you can see, the middle part, the central part, is burnt out. So during the first night, I took 14 subframes, 2 minutes each, and during the second night, I took M42. I think I took about 41 frames, 2 minutes each. So altogether, I have 60 10 seconds frame and 55 120 seconds frame. So the first stage of the processing is to stack these frames, but both sessions, both sets of subframes, the set with 10 seconds frame and the set with 2 minutes frames, have to be aligned to each other. So first, let me open all the frames which are 10 seconds long. Yes, so first let's open 10 seconds frames. I also made flats, so I will open flats. I took 60 flats, and I also have 60 biases. Yes, 60 biases. So after opening lights, flats and biases, I check all, so all the frames are checked. And the stacking method I choose was, it has to be, the result has to be in a standard mode. For lights, I choose kappa sigma clipping with standard settings. I choose per channel background calibration, just in case. For flats, it's median, and for biases, it's also median. So, like I said, I will not be stacking them now because I already did. After registration, one more thing, you have to set the star detection threshold to a correct value. For the 10 seconds frame, for the 10 seconds frames, it's about 10%. The star detection threshold has to be about 10% or even a little bit less. So there is enough stars found in the subframes, in the 10 seconds subframes. So after stacking, we will be getting the first stack. Yes, it's autosave 60 times 10 seconds. So this is the first stack. We have a lot of noise in the surroundings of the nebula, but the central part is not overburned. Wait, let me decrease the stretch a little bit. Yeah. As you can see, the central part is clearly visible. We have data here. So this is a stack made from 10 seconds frames at ISO 400. So this is the first stack. And now this is an important part because we want to register the second set of subframes of 120 seconds subframes. We want to register them on one of the 10 seconds frame, the best one actually. So after registration of the 10 seconds frame, there is a score assigned to each of the frame. So what we need to do is we keep the frame which has the highest score. In this case, it's 600, the value of the score. So we keep this frame and we remove all the rest of the light frames, of the 10 seconds light frames. So I mark them all, I select them all, and I choose, I click right mouse button and I choose remove from list. The flats and the biases, they will stay as they are because I will use them for the second set of subframes. So this best frame, 10 seconds frame, is left on the list, and now I will open the rest of the frames, the 120 seconds frames. So these are the first 14, and open picture files. And these are the frames shot during the second night. So now again, I check them all, but I have to uncheck the one which will be our reference frame, this one which is 10 seconds long, the best one of the 10 seconds frames. So I will uncheck this frame, but I will press right mouse button on this frame and choose Use as a Reference Frame. In this way, all the rest of the light frames will be aligned to this 10 seconds frame. For the longer frames, for the 120-second frames, you need to increase the star detection threshold because they are lighter, they are brighter, so the 10% value which we used for 10 seconds frame will be too low. We need to go up to about 60%. If we compute the number of stars, yes, it's 96 stars, so it's enough. So yeah, this is the summary of the 120-second frames set. It's about, like I said, 2 hours of data. I will not stack them because I already did. As a result, I will be getting this stack. 55 times 120 seconds. As we can see, all the structures around the nebula are visible, but the central part is burnt out. If we zoom in and decrease the brightness, even if we go very low with the brightness, we still can see that the central part is burnt out. So what we need to do is to make HDR, high dynamic range photo. So we need to combine those two stacks, and I will show you how to do it. But before, I will run both those stacks through GrackSpert to denoise them. So it's very easy. It's nothing difficult. I will just show how I do it. So let me open GrackSpert. I will load the first stack, the one made from 120 seconds subframes. And to denoise this stack, I'm not making any crops, I'm not making any background extraction, I just choose denoising. And the denoise strength I set to 0.8. So it's enough just to press denoise image. It will take about 30 minutes on my computer, so I will not do it now because I denoised this stack previously. One thing which is worth remembering is that after denoising, you have to save this denoised version. Once or twice I forgot to save the denoised version, so I had to run the denoising process again. So I just remind you to remember about saving the denoised version. So yeah, this was the first stack, and after denoising the first one, I opened the second stack, and I did exactly the same, namely I denoised this stack using the strength of 0.8, and then I saved the result. So the outcome of all this is denoised stack from the longer subs, denoised stack from the shorter sub. So now when I open the first stack, the one made from longer subs, and when I switch to the next stack, the one made from shorter subs, you can see that they are perfectly aligned to each other. And this will make very easy to combine them later in GIMP. So the first thing to do is to open both these stacks in Siril and prepare them for high dynamic range combination. And now let's open the first one, the denoised version. And first thing to do is to make the color calibration. Make sure your internet connection is active. So it's image processing, color calibration, photometric color calibration, M42. The object is found. The focal length of this telescope, of the ED80 with the reducer, it should be 510, but the astrometric solution gives the value of the focal length 520. Pixel size of Canon 450D is 5.2 microns, so it's okay. I press OK and the photometric color calibration is done. So this is the first stack after color calibration, and now it's the important part, because I need to stretch both stacks in a way which will allow for easy combination of them in a moment in GIMP. To do this, I make it like this. I found an area in the center of the image, more or less in the center of the image. I remembered the coordinates of this area, so I chose here we have the coordinates in the lower right part of the preview window. So I chose coordinates of x, 2000 for x and 1430 for y. And I made this selection 50 pixels wide and 50 pixels. The height of the selection area was also 50 pixels. And in this area, I will measure the brightness, because right now I am in the auto stretch mode. If I switch to linear, it will the stack will be in its original brightness. So now I will be stretching this stack, but I will measure the brightness of this selected area. So first, with the selection active, if I right click on the image and choose statistics, then it will give me statistics of this selection. So I will pay attention to the value, the mean value of the green channel. Right now it's 3250. I want to stretch it more. So let's choose histogram transformation. And let's stretch the image. Not too much, you have to be careful. And let's measure it again. It's 15,000. So this is the value during my previous processing. I found that the value of 15,000 is more or less okay. So right now the image is a little bit too bright. So I can make it a little bit darker. Let's check. Yeah, it's 14,000, almost 15,000. So okay, let's keep it like this. We can close this window. And we can close the statistics windows as well. So what I have done is I stretched the stack made out of 120 seconds subframes. I stretch it so that the area in the central part is about 15,000 ADU bright. So right now I will save this stretched stack as 32 bits TIFF. So let's choose TIFF and let's change the name to stretch 15,000. And I will choose 32-bit floating point for now. So let's save this image. And now let's open the second stack, the denoised version of the second stack. And again, the first thing to do is to color calibrate this stack, photometric color calibration. The values for the focal length and pixel size are the same. Okay, the image is color calibrated, and now again I will make a selection. Again with the same coordinates here. So it's x 2000 for x and 1430 for y. And the size of this square is 50 pixels. 50 pixels wide and 50 pixels high. Okay. Now let's switch back to linear. Let's measure the brightness. It's about a little bit above 200, so let's stretch the image. Histogram transformation. Apply. Apply. Let's measure it again. Almost 10,000. So let's stretch it more. Okay. 17,000. It's too high. So let's make it darker a little bit. 15,000. Okay. 15,500. Oh, let's try this. 14,800. Okay. Let's make it a little bit brighter. Okay. It's almost 15,000, so very, very close to the brightness of the same area on the first stack. So let's click apply. Let's close the histogram window. Let's close the statistics window. So right now let's save this stack in TIFF format as well. Let's name it stretch 15,000. Save. And I will save it also in 32-bit format. Okay, so now what I will do is I will open both these stacks in GIMP, to combine them. Okay, so let's open these two stacks as layers. Expansion, astrophoto. So I open both stacks, the versions stretched to 15,000 ADU brightness. Okay, and now all I need to do is to combine these two stacks. How to do it? It's very easy. The stack made of 10-second subs is on top. So what I will do is I will simply add black layer mask. So add layer mask. Let's make it black. Don't invert it. by adding the black mask, I made this layer disappear because the black mask is hiding the whole layer. But if I will paint white on this black mask, I will reveal parts of this layer. So let me choose airbrush. Let me set colors, the foreground color to white. And now if I will paint on the white, on the black mask, I will reveal parts of this layer. So with this mask active, you need to have this white frame around the mask. If you now paint white, you can see that the stars became smaller because by painting on the black mask, I will reveal parts of the layer containing the stack made of 10-second subframes. So okay, right now both these layers are combined, are merged together. If I press right mouse button and choose Show Layer Mask, we can see how the mask looks like. I can blend the borders of the mask just to make these two layers blend better. So let's choose, with the mask still active, let's choose Filters, Blur, Gaussian Blur, and let's blur it by 5, let's say. Okay. So now, because of this blurring, the borders between those two layers, the visible part of the one layer and the rest of the second layer, the borders will be more smooth. So if I deactivate Show Layer Mask, we can see the result. Two layers are combined. So now I will press New from Visible, and now what I have to do, because we need to stretch the image, the resulting image, to run it through StarNet. But for this, the image has to be bright enough, because if the image will be too dark, after removing stars in StarNet, there will be artifacts on the image. So we want to stretch it. We want to stretch the image to make it brighter, but we have to watch what is going. We have to protect the middle area, the central part, to not burn it out. So what I will do, I will first, as usual, duplicate the layer. So I have a spare one just in case, and I will stretch this duplicated layer, but I will make a selection. Yes, I have to choose the right mode for this. So for this, the first mode, replace the current selection, will be the correct mode. So I will protect the central part by making a selection around it. I will feather the selection, let's say by 200 pixels, and then I will invert the selection, select invert. So I will stretch only the rest of the image, not the central part. Let's see how it goes. Colors, levels, and let's stretch it. And let's increase the contrast. Oh, too much. You have to pay attention to the histogram. So to be sure that you are not clipping any data. You don't want Oh, you don't want such situation that the part of the histogram is clipped. We want to have the whole background without any clipping. Ah, wait, this is not this slider. Oh, okay. Okay, so this is the first stretch. Let's click OK. And let's make this stretched part a little bit darker. So we change the black point. Okay. And now let's select none. And I will select maybe a bigger area of the nebula, like this. And again, let's feather the selection by 200 pixels. And let's invert the selection. So only the rest of the image will be affected by my stretching, and the central part is protected. Colors, levels. Let's make it even more bright. Let's click OK. And let's move the black point to the right side, making the image darker. And I think maybe a little bit more. Okay. All right, so now I think the image is correctly stretched for now, so I choose select none to remove the selection. Okay, so now I have to save this stretched image as TIFF again, because for some reason when I try to export 16-bit TIFF straight from GIMP and load it into StarNet to remove stars, StarNet doesn't want to recognize the file. Well, I mean, it loads the file, but it says that there is something wrong with the file. So what I do is I export the stretched TIFF from GIMP. Let me export it. I added the 32 bits part of the name to it. Replace it. There is one important thing. You should uncheck save layers. We don't want to save layers in this TIFF for Siril to correctly recognize the file. Alright, so now let me switch back to Siril and I will open this file we have just exported from GIMP. Here is our stretched version. And now what I will do is I will just save the file, but not a 32 bits version, but 16 bits version. Save 16 bits unsigned integer. That is the format I want, because this format made in Siril will be recognized by StarNet. So let me open StarNet. Let me choose browse, astrophoto, M42, and this is the version we are interested in, the 16 bits version generated by Siril. So let's open it, and as usual I will add no stars here and press run. So StarNet will begin to remove stars from this file. It will take some time, so I will stop the recording and I will be back when StarNet finishes removing stars. So see you soon.